Is the recording in progress. Got it. This is the Riverside Robotics Society of Southern California's joint meeting. Welcome, everybody. How's everybody doing today?
Good. Good.
Morning, we have Dan Albert there, so give a wave, Dan. After we go through a few things, we're going to have Dan give his presentation. He's got a few robots that he wants to show off. So he'll be the guest speaker for today. Let's see, going down the list. Do we have any business items? Any business items on the line?
Well, someone did mention that the Riverside Club's meeting in person next month.
Yeah, we are. And we have people screaming in both directions. Yay. And oh my God, what are you guys, crazy? Little bit of both. Well, you know, after all this time, we haven't met in person for more than a year. And the Riverside Library is open for business. And they called me up and they said, do you want to schedule a meeting? And I thought about it and talked to Alan and thought about it and looked at my, I got the dog just walking. Hello, dog. You know, we don't think things are going to get much better in the next year. We just see another wave after wave of this stuff. And I'm vaccinated and I can't and won't check vaccinations, but we will require everyone to wear a mask and social distance, everything you've been doing for the last year plus. I know you're not going to like it. And unfortunately, we just have to cover our butts here because if somebody did get sick, you know, we could be liable and we don't want to be liable because we're a nice bunch of guys here and ladies. And if you want to discuss that further, send me an email. I'm going to be glad to talk it over with you. I know we do have a few people who are sure they're coming. Our first meeting is going to be light and short. It's only going to be 2 hours. No eating or drinking either, because you have to take your mask off to eat or drink. Anyway, so yes, we are ruffling feathers both ways. Some people go, oh my God, you can't have a meeting. And some people say, how can you have a meeting and make everybody wear masks? Well, you know what? We're just going to ride the fine line down the middle and do the best we can. Can't please everyone. Anyway, that's it on my end. Anything else, Alan?
That's all I can think of.
All right. Yeah, you know, I've been hearing a lot about the different cameras available, and Jim's been talking about his camera. What's the brand name of your camera again, Jim?
The Luxonis Oak D, yeah, I'll type it in the.
Yeah,
I'm starting to work with it again right now, and then I bought a new, or I pledged a new Kickstarter for their small version. They have but the support is incredible and it keeps going and going, and it can handle this OpenVINO, all the Intel machine models, which is called OpenVINO, and it's like I could spend a year just on this camera, all the different AI things it can do.
Hey, Jim, that gives me a good idea. Why don't you do a presentation on the Oak D camera? Can you do that? I know I'd love to hear about it. I'm sure a lot of other people would too.
Yeah, I guess, yeah, I could do that. It might be a good idea. Put together a slideshow and.
Yeah, tell us all about it. Tell us all the pluses and minuses and maybe walk us through getting it started from the beginning. Because I'm sure something like that doesn't just start out of the box. You got to, you know, fight with it for a few weeks, months.
Yeah, I mean, there's a learning curve, but it's getting better because of the contest generated like a GUI app that you can design your own models very easily, like with Blocky and you know, the Blocky type of programming, and so that's improving too, the usability, because of all the because of one particular third party that really, they won the contest, in fact. Or
all right, well, that's for Well, we'll talk offline. We'll figure out when we're going to do that. Okay, Jim?
Yeah, let's, I'll think about it.
Maybe December or something.
Yep.
Oh, I have an announcement and any other, well, since we're done with business, how about announcements? I have an announcement. Anybody else? Going once, twice, three times. Okay, here's my announcement. The November meeting, we will have one of the drivers of the Mars rover, the latest Mars rover will be giving a lecture for us. So that should be exciting. As you know, the Mars rover is 99% robot and 1% person planning out the trek of this thing. So we should, I'm looking forward to that. That'll be in November, the first weekend in November. Back to the Riverside Club just for a second, just so you know, we're not overlapping. The meetings for next month are going to be, let's see, I want to get that straight. So that would be October 8th, which is a Friday. That's the first, that's the second Friday of the month. And then the Riverside Club will meet on the 16th in person. And then the 23rd of October will be the second joint meeting. So there'll be 3 robot meetings next month. So there you go. There you have it. And if you're going to the Homebrew Club, well, you've got your calendar full of robot meetings, don't you?
Yeah.
All right.
Yeah, that's true. We should mention next Wednesday.
Yeah, go ahead, Dan.
It's the Homebrew Robotics Challenge every 3 months, I believe. And so it's going to be 5-minute, it's all show and tell, 5 minutes to 10-minute each for like 20 different robots of all usually very high caliber. So I highly recommend that. That's next Wednesday at, I believe, 7 o'clock. And I'll post the link.
Yeah, and my Simone's going to be there, and she's not quite ready for prime time. I got to clean this thing up and get it working again. She's all torn apart.
Yeah, I'm not ready either.
Oh, I've been writing these articles for Servo magazine. I'm up to my 4th article, I think, about making this fembot over here. So I built it, and then now I have to take it apart to remember and figure out how I built it, because I don't remember it, because that was almost a year ago now.
Well, you should have took more photos while you were building it.
You're right. I should have that video camera running 24/7, but I didn't. Thanks, Tim.
Well,
Any other announcements before we move on? Okay, moving right on. It's 10:13. Oh, I got announcements. We got that. If anybody wants to give a presentation, we can give you 30 to 60 minutes. You'll have your choice of either the Friday or the Saturday meetings. Just drop us an email, put it in the mailing list, call me, my phone number. I'll put it in the chat bot, in the chat. We're always looking for people to talk about their favorite projects, teach us something new, tell us about something wonderful that's happening in the robotics world. We're always looking for somebody new because, you know, myself and Alan and Jim, we get tired of talking, you know, it's a lot of time it's us 3. So we're welcoming people to do that. And speaking of guests, we have our guest speaker today, Dan Albert. Hello, Dan. Are you ready?
Well, I'm never ready. So hold on a second. Let me get back to where I can see myself. Okay.
Okay, we'll give the floor to you, Dan. You got it.
All right. First of all, a few things. One, as I seem to have contracted laryngitis or something, so I apologize for that ahead of time. I don't normally talk like this. Second, they were supposed to shut my power off. I live up in the hills here at 9 and turn it back on by 9:30. They've yet to turn it off. If it goes out, I'll just lose the link and I'll plug into a backup power system that I have, which will take about 30 seconds or 40 seconds to reboot the router, and then I'll come back on. But hopefully they won't shut it off. So what I really wanted to talk about today was what I've done for the last few years, well, since 2007. And the camera's a little unstable because I'm going to move it around as I show things. It's not the PC camera. So my interest with bipedal robots started in about 2005. So I've been doing this for 16 years, and I've learned a lot of lessons, a lot of things you can do and should do and shouldn't do. And Thomas is building a biped, so he kind of knows the trials and tribulations of doing that. But anyway, I got sort of interested in this when Robo Games was out here in 2005. I was on the East Coast, and I bought a Robo One style robot, which Chris Mayer has now. It's called Roberzoid, and if Chris, I think you're on. So if you want to show a picture of that, that's fine too. And then I moved into these guys, which are, you know, really great 2006 technology, which I have to say has not been improved that much. These were controlled through an IR thing on the top. We scrapped that and put a Zigbee inside, took and hacked some PS2 controllers, which are SPI-based, and built a little microprocessor to, you know, connect Zigbee, and basically we made soccer bots out of this, and we were playing soccer. Dave Calkins and I were on the USA team, and we had teams from across the world, and it was a lot of fun. And I go, well, you know, if this little robot is bipedal and can do all this stuff, maybe I can build a big one. And that was kind of the first dumb idea that I had in 2007. And the first mistake I made was expecting that the servos ratings, the RC style servos ratings, were anything near what the manufacturer published. And everybody now knows that that's not true. You're lucky to get half of that. And so I built this 4-foot robot. Let me back up a sec. I just want to say one more thing before I get into the big robot. So back, I also have been working with Servo Magazine. This is from 2007, and it's online, but it's very interesting how the technology has not changed. And the important article that I wrote for this was how to do a sort of semi-dynamic walk using static frames. These particular Robo One robots, basically you did a static frame. You kind of went, okay, like this, then you did this, and then you did that, and then you tied them all together over time, and you got the thing to walk, and they had big feet, so they didn't fall over. What I came up with when I rewrote the OS for this robot, Atmel 128, in order to be able to do something that was not just static frames. And so I created a frame sequencer, published it in Servo Magazine, willing to share it with anybody if anybody ever wants to use it again. Probably not, because the technology has changed. But it was a very interesting experiment working with different frames and trying to control the mass of the robot. And as we know, as we get larger in size and larger in mass, the problem kind of is exponentially more difficult, and mostly because of slop. The mechanisms just aren't stiff enough. And so people then started building bipedal robots using harmonic drives, very stiff, zero backlash drives, planetary gear systems and everything. And ultimately, they were able to build robots. And I don't think that too many people have changed this paradigm for bipedal robots lately. And I don't think it's ever going to work. I don't think, yes, Chris and I used to laugh about Boston Dynamics bipedal robot because it had a power supply that was the size of a car that it had to sit next to. I was like, yeah, okay. But it was an experiment. And now, of course, they have a robot that can do backflips and run, and it's really fantastic, but it's not monetizable. And I don't even know if that's a word, but basically, you know, there's a reason why Boston Dynamics doesn't sell household bipedal robots. It's impossible given the current technology. They're very dangerous. And, you know, my robot, you know, weighs about, I don't know, I'd say 75 to 100 pounds. And the torque on the motors is extremely strong. And, you know, when something bad happens and it tries to just do positional control, people get hurt, including me. You know, I've been knocked on my butt a number of times because the robot just glitched. And something happened, and I, you know, you get punched in the face or whatever, or you get your finger caught, and it's ow, 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 and you're sitting there trying to smack the power off button on the back, and you can't reach it, and it's a, you know, so now I just did yesterday I just did the test online, the coding test for Tesla, because they're building a bipedal robot, and I want to get involved in that. I'm looking at what these guys are trying to do. They're basically saying, oh, we're going to build a bipedal robot in a year, and we're going to monetize it, and we're going to make it a household item. And I'm thinking, you guys, that's a great, great thing to want to do, but you've never done it before. You've just got great ideas. And, you know, we all have great ideas. We're going to build this. I mean, that's how we end up with these stupid 10-year-old projects that seem to never, you know, get to completion. You can't design and build a bipedal robot that works and is monetizable in a year. A lot of companies have tried, and I'm hoping that, you know, it would be kind of a dream job to get the financing of Tesla behind the kind of work that I've done, and just kind of make sure that they don't go in the wrong direction. So let's talk a little bit then about what works and what doesn't work. So first of all, let me see if I'd like to actually just throw a picture up here, if I can, of the type of motors that I used in Karen, which was originally called Watson, but that was just an acronym of, I forget what it was, without a tether, I think. Without a tether, something stereoscopic omni navigator. It was Watson. And Chris and I thought it was funny at the time because Boston Dynamics robot had this big tether system, and we were not. But anyway, so we used spur gear motors, very high torque spur gear motors in Karen that had a lot of slop, but they're very cheap. And I thought, well, you know, you want to build a robot that's somewhere around $5,000 and $10,000. And I don't know if everybody's seen Karen. Have people seen the big robot? And should I just try to put a picture up there? Let's see here.
I'm currently uploading a bunch of photos to a Google Drive, and I just posted the link.
Yeah, but
however, it's going to take a while for them to all get uploaded.
Okay, so if I want to, I've got a picture here on multiple screens. Can I sort of switch over to that screen while I'm talking?
Share your screen.
Zoom. Yeah, but can I share the others? Does it let me share the other screen? I guess
It shares whatever computer you're on, so share the screen on the computer you're using.
Okay, I'm going to share a screen too. Okay, so can you see that?
Well, that's cool looking.
So I don't know what you're seeing. Are you seeing?
It says
Karen,
Karen,
right?
and she's got a black shirt on.
Yeah. So a couple of things here. First of all, you'll see the blue and yellow bands that are there, and so ultimately adding elastic to the system really. Yes.
Dan, can you zoom in on that? There you go. Oh, that's much better. Thank you.
Sorry about that. Yeah, it's big for me. So you can see, I don't know if you can see my mouse, but you see there's a blue band here and a yellow band. This is surgical stretchy stuff that is just wrapped around, and it's kind of set up so that the joint will only go so far before it kind of just pulls on that elastic and stops moving, which is really great because ultimately you can set up a robot that just stands without any energy. And that's kind of what you want. It's for a household bipedal robot, you don't really move, you know, the watching grandmom and everything, you're not really moving that much. So you're sort of standing there, but you need the ability to move. But most of the time, you're kind of just watching grandmom, who's also not moving. And it should be zero energy when you're not moving, as far as your motors are concerned. And then, you know, when you move, then you have to sort of fight your way out of this stretchy position. And that was kind of one of the things that I was doing. Now let's see if I can move. I want to share my other screen here. Give me 1 second. Go back to.
Yeah, it's pretty cool looking, Dilbert.
Thanks. I always have trouble with Zoom here. And there it is. Shares.
So where is she now?
Oh, so okay. Well, right now, okay. So she's right over here. So let me go back to my other screen. But of course, I'm having trouble finding the little button now. Where's the thing? Oh, I got to go up here and get it. Okay, new share, pause. Okay, so I'm gonna go back to screen 1. No, I want to go back to my camera. Hang on.
Or your camera's still.
So my camera's still on. Okay, so I want to just basically stop the share. So are we back? Are we back on the camera now?
Stop. If you want to stop the share, you got to go up to where it says stop share. It's up the top, I think, usually.
Well, there's stop share. Okay, great.
Stop share.
Got it. All right. Thank you for that. Yeah, I paused the share. So this is Karen right there, and I'm going to zoom in sort of real quick, and then I'll talk about it of the load cell. Round thing at the bottom. Right there. I don't know if you were able to see that. Were you able to see that?
Hey, we can't hear you.
Oh, were you able to see the load cell at the bottom? Anyway, I'll just talk about it because it really is not important that you look at the load cell. So the original idea was, and this is also in Servo magazines, was to have some very accurate load cells at the bottom that measured the weight. And I had worked for a load cell company, so that was really good. I could get these very expensive $200 load cells. And originally I had 3 and calculated the center of mass because I had a foot with a heel and 2 points near the toes. Ultimately, that was not stable enough for the mechanism. So I went back to a really square foot that just so that it wouldn't fall over. And Chris, I don't know if you have any videos of Karen walking. We have a couple that are somewhere on the web. I don't seem to have them.
Yeah, I actually have a lot of videos, and I just posted them to a Google Drive.
Okay.
It might not be there. Google Drive has to process them before you can watch them, but they should show up in the next few minutes.
Okay. And you know, you guys can watch them. It's kind of a really clumsy walk, but it does walk. And you know, the reason it's not walking now is because the company that makes the little gearboxes in all the servos, these they weren't very expensive, but they were very heavy, very torquey servos. The company that makes the gears inside decided that they only want to sell servos. They don't want to sell gears. And ultimately, the final gear would always strip out, and I'd have to keep replacing these gears every time the torque went, you know, to infinity, and basically was just waiting for something to break. And that was this little 13 gear, you know, 13 pin spur gear, and all the pins, you know, all the edges of the gear would just snap off because it just couldn't take the torque. And
What were the gear? What were the gears made out of?
they were made out of hardened steel, but of course, hardened steel is why they snap, because they're hard. So ultimately, let me just grab one of these motors here. Ultimately, I've changed my design and I've moved to these. So if you've seen some of the Spot stuff, you'll recognize this style servo. Very torquey. You know, I'm somewhere, you know, 9 to 18 Newton meters when you know, depending on what software you're running and how much power you want to consume. So inside this is it's a standard 3-phase DC motor that's used in airplanes, kind of those little small airplanes, you know, RC stuff. And then on the outside is combined with it is a 6-to-1. This is a 6-to-1 planetary gear set. So you can see how back drivable it is. It's very back drivable, but it's also very torquey, and it has, you know, virtually zero slop to it. And so this is the style you want to use. Get away from, you know, the spur gear motors. They, you know, they're just sloppy, and to hold a position, because this is the same, to hold a position, you basically have to apply power, which is not what you really want. So you want to add some series elastics into your system to sort of have your robot hold the position that it needs to hold when it's whatever it is for like 90% of its time. With that robot, I'm going to go to some other pictures here. I've decided that I'm going to, that bipads were basically just too difficult for the type of robot that I wanted to produce and sell. You know, it's just impossible. Like I said, I don't think Tesla's going to do it. I don't think Boston Dynamics is going to do it. And Dan Albert's not going to do it in his garage. So I switched to quadrupeds and want to sort of show my quadruped as soon as I pull a picture up. But of course, I have to put them in a different folder. Okay. So I'm going to open this one up again and share this screen.
Hey, Dan, I have a question.
Yeah, sure.
Did you ever get Karen walking?
Yeah, there's 2 videos. That's Chris is going to actually try to find one of the ones. The walks were very clunky, and I think we took like 4 or 5 steps and basically called it a day.
Right.
But 4 or 5 steps is pretty good. You know,
So
I mean,
far, yeah.
you know, I mean, taking 1 step is pretty good. Let me go here and share my other screen. Okay. So now you see, I'm assuming that the share, wait a minute, is not on there. So can you see this robot here? This is the dog robot made of these, these quasi direct drive servos. And I did not build this robot. I built an upper body that sits on top of this robot. And let's see if I can, that's it upside down. So then I also put, this is the NVIDIA Nano that now Chris has. I've upgraded to an NX and stereoscopic vision. This is the first upper plate I designed. That's fuzzy. That was the battery holder, the neck servo. These are some old pictures, so I'm going to stop sharing that and share something else. So now, I don't know if you can see this. This is the current. Are we back to my camera, by the way?
Yes.
Okay, so this is the current. I removed, I had a really crazy gantry system for the head because I wanted it to be able to reach out. And ultimately, the servos I was using, again, these, you know, RC style servos are just too stiff to do the job and not strong enough. So I went back to just rotating the head and tilting it up and down. So that's the head. Inside the head, I don't know if you can see it. The light's kind of crappy. Let me turn the light on. I don't know if that helps any. Inside the head is inside there, and the important
I think, careful, I think you're covering the microphone with your thumb or something.
well, can you see?
We can't hear you, Dan.
Like the
See
head.
that was the microphone. I have two microphones in the ear, and I have a uh-oh, come on, adjust the light automatically for me. This camera's kind of crappy.
Can't see anything right now.
Yeah, I know. I'm just trying to.
We're losing your audio, like,
Okay, well, I'm gonna go back and just talk about it then, because ultimately,
is the,
But by the way, Jim, your OneDrive is up. I looked at the video of it walking.
okay, so my camera has sort of this camera's kind of gone south. Let me start video here again. Let me switch cameras. All right. Sorry about that, guys. Yeah, I need to get like a better camera system and lighting to do these, but I just didn't have the time. So ultimately, the dog robot has a vision system. And it has audio input and audio output. I've been working with the latest NVIDIA software, been working in PyTorch, got the Torch Vision up and running. The Torch Audio didn't work. I just got that built from source. So I now have Torch Audio running on there. And then it's just sort of a question of getting some commands for speech recognition. Ultimately, then I just convert it to tell the dog which command to do. And that's sort of running a Raspberry Pi 4, I believe, inside there. And I'll just, through Ethernet, send the commands over to do different things. And that's sort of the goal with that, is to have the first dog that can pass the AKC dog test, level 1 obedience. It's a goal that's doable. Unlike, Karen walking is great, but ultimately is a very difficult task and may not be achievable without, complete redesign. And a complete redesign is kind of where I'll go next after the quad is completed. So that's kind of everything I have. I hope that was enough for now.
That's fine, Dan. Thank you very much.
Well, thanks. I'll be happy to take any questions for the original design, the things that I've done differently, the lessons that I've learned, what not to do, that kind of thing. Does anybody have any questions at all?
Well, yeah. Hey, so I noticed you're moving over to the brushless. What are those, 7-to-1 or 5-to-1?
These are 6-to-1 planetary gear set quasi direct drive.
Wow.
And have you just gotten started on converting Karen to them, or have you
I'm
been at
not
it for a while?
so I have not converted Karen to them. I would probably just rebuild Karen from scratch.
Okay.
It'd be just like a whole new model based on this. It'd be all catted up and all designed ahead of time. A couple of the things that I didn't think about with Karen was how to have the robot stand using no energy. So I sort of wanted in that almost what Chris calls the Da Vinci pose, but basically just kind of standing there with the arms that, ready to go, but not doing anything. Just not expending any energy at all, because ultimately batteries are going to be a big problem.
Did you look into banded brakes?
No, but people have told me to put those kind of brakes on. But my question is, do they have, are they two state, meaning you only expend energy when you change the state, and then they'll either lock or unlock?
That depends on the activating mechanism. I used to work on tape drives.
Yeah.
Brakes. One kind was like you're talking about, where it was active braking. There was another kind where it had, the mechanism was made up like a toggle system where it would either lock or unlock on the
Right.
impulse.
Yeah, that's kind of what you want because, and multiple people tried to tell me that, but I kind of thought that, you know, rubber bands might be easier or stretchy material.
I don't think they would be. The band brakes really were mechanically simple. I've just looked them up here trying to find them, but the tape drives were made by God, who was it made that terrible rust-colored tape back in the day? I can't remember the name of it now, but they were the equivalent of Kodak for magnetic tape recorders for video, and I just can't remember the name of the company now. But they had the one that had the toggle mechanism.
Maxell?
I'm sorry?
Maxell?
No, Maxell builds good stuff. This stuff was like crap. That if you exposed it to too much heat, the magnetic stuff would fall off of the tape. I just can't remember the name of it right now. They went out of business, obviously. But they did have a mechanism, and it seems to me like it was only one solenoid. But when it impulsed the first time, it would lock the brake, and when it impulsed the second time, it would unlock it.
So I've seen people build robots using those. Ultimately, you want to move away from the Karen design. My original design was the Joe knee walker, and that was where I had the leg servos in the knees and didn't have anything at the feet. Ultimately, because the moment at the end of the leg was just so heavy that you really walking was difficult, because when you got on one side, when all your weight was on one leg, that other leg was just wanted to just throw the whole system around, because you know, and you'd have to sort of try to balance the whole system in one point while one leg is in the air and the other one's planted. It's swinging around, and the whole moment of the robot is kind of falling off from this huge weight of the 5 servos from the knee down that would controlling everything. So weight at the end of your, you know, your end effectors basically is not a good thing. You want to keep that as light as possible. And so, you know, mechanisms of similar to the electric, what was that typewriter? The Selectric typewriter, if everybody remembers that, was a fantastic mechanism based on very tight wires. And, you know, this is 1950s technology that today you should be building robots from, something like that, because it, you know, it's lightweight at the end, because all it is that, you know, all the power's somewhere else, and you want to keep all the weight at, you know, right here in the chest.
I always think of Leonardo's armored knight.
Yeah, I have a picture of that.
Internally, that's all cables.
Well, when I was over in Italy, in Milan, they have a lot of that, a lot of museums like that, and I went to every one. It's like, oh yeah, I got to see all those cool robot things.
Those motors that you showed just a minute ago, how much does that cost?
These motors are somewhere, I'm guessing, around $300 to $400 a piece. If you buy quantity, you probably can get them down to $250, which is not unreasonable for what you're paying. If you think about what you pay for one of those Robotis motors, I like this. This is just lightweight and easy to. I mean, 2 of these at a joint working together would be really strong, really lightweight. Yeah, I love them. I think they're great.
Albert, I have a brief question for you.
Sure.
This desire to have a humanoid type of robot not use energy while it's just standing still, that type of thing. When you think about biological entities, the animal kingdom and humans, we're constantly expending energy with our muscles in order to keep us in stable positions. Do you really think that it's possible to build some kind of robotic device that actually defies gravitational pulls and all that without expending some kind of energy to maintain balance and everything?
Yeah, well, I think that if you balance, if you okay, zero energy, maybe not, but minimal energy, yes. And you have the pull of gravity against the elastics. And I think that's basically what holds the system together. So basically, if you can get elastics at each joint, and you can do it in simulation first, you'll see that the gravity sort of wants to pull everything down and hold it in place. And there gets to be that the point at which the spring is just sort of basically taut and fighting gravity, and it's balanced against gravity. So I do think it's possible.
A simple example is a bicycle stands up with a kickstand and expends no energy to do it.
Right. Yeah.
So once your motors are locked, if you're balanced, should be zero energy.
I mean, unless you get pushed over, right? I mean, that's always the problem. So it has the system has to react fast.
This kind of dictates that the actual motors themselves have to be designed in some way that they retain their position when no energy is applied to them. And that sounds like an engineering challenge for the design of some kind of new style of motor in a way.
I was thinking,
your thoughts on that?
Yeah, so I was thinking of something more series elastic, meaning that, in series with the motor you have, or it can even be parallel elastic. I don't really care. It basically is you're fighting the elastic when you want to move. There's a position where there's like the zero moment position where the elastic isn't doing anything. And then if you go one way, it fights it, and then you go the other way, it fights it. And at some static position, you're not expending any energy. The elastic is doing the job and fighting gravity. So I think it's possible, and I wouldn't build it into the motor. No, I think that ultimately artificial muscles will come around. Someone's going to build them, and some kind of electrostatic muscle or something that changes its shape like nitinol or something, but is lightweight and not energy consuming.
Right.
And then we're going to start switching over to those artificial muscles, and the motors will go away. So I'm kind of thinking now you might want to just do this elastic thing and just
Yeah.
I don't know. I'm going to design one and build it.
Right.
See what happens.
I always kept saying it until go ahead.
The other thing I was thinking about was these.
I was just going to ask. So, one last question to you then, from your standpoint or your understanding, because you've presented it pretty well about Boston Dynamics not having a commercial robot, humanoid type robot for sale, stuff like that. What is your take on what it would take in order to have the kind of robot that actually has these safety features, some kind of sensors or something that would prevent it from being very dangerous to a companion human, if you will, and make it a viable kind of commercial product that could be sold to the public or whatever, that would not have the liability aspects of injury to a human or any other animal.
That is the big question. That's a great question. And sometimes we have to say, what's the question? And I think that you're absolutely right. There sort of needs to be a change in technology. And I don't know the answer, but I know some of the problems that need to be worked around. One is, you probably should not build your robot out of anything metal. Sorry to say, I build them all out of metal right now because the technology sucks. All we have is magnetics, and magnetics will not in the sense that we have magnetics now. we're going to need material science is going to change, and we're going to have to somehow get away from motors. You cannot build a safe robot that is lightweight. I mean, someone says, oh yeah, you can have it control the amount of pressure based on the current, and you can have it smart, and it can sense when somebody's touching it and move out of the way and all that. And I go, yeah, that's a conditional kind of experiment. You're basically writing some kind of program that's conditionally try to not hurt somebody. But ultimately, shit happens, and the robot's going to fall, and it's going to fall on grandma. And if it weighs a lot, it's going to hurt grandma. I know this because I've had Karen knock me on my ass, and you know, it hurt. Yeah. It's like, ow, that hurts when a 150-pound robot falls on you. Now, Karen's not 150 pounds, but Boston Dynamics, you know, you don't want that robot's gonna kick your ass.
No, no, that's why it's got a roll cage around it.
Yeah. So this, you know, as a publicity stunt and a proof of concept, I think it is a great publicity stunt, and it's a poor concept because it's not ever gonna, at the weight, at anything over a full-size 4-foot robot should weigh no more than 40 pounds. Because
so basically, I guess we have to wait until technology brings us artificial muscle in a sense. I've thought about the idea of trying to invent some kind of artificial muscle, and it's not a trivial project.
No, I mean, there were people who thought of using some sort of single engine, you know, so you only have one motor that drives either a hydraulic system or something like that, you know, to come up with a new type of muscle, because air muscles are so strong, but you know, air is easy to divert. And so, you know, you get kind of movements like this with air when you're trying to control it. And so it doesn't control easy.
Plus you have to have the right kind of air containment type of mechanism, and it's that part that creates the weight and the mass and everything also. So in order to just kind of contain the air for doing hydraulics in essence.
Yeah, I often thought that you could use the material that they use, that like in potato chip bags, that metal film. My girlfriend sells packaging, and she'd tell you exactly what it's like, polyethylene or something like that. But basically, these materials are extremely strong and hold air well. I mean, how many times have you take a bag that's been just heat sealed, and you try to open it and you can't? Well, that's because the machine that seals it actually did too good of a job. I mean, they actually have to tone that down so that you can open the bag, but they could theoretically seal those things. And you could build a system based on air if you could make those little pockets, you know, if you use, let's say, 1,000 pockets of little pocket things that bellows that can open and close. And you could theoretically build some kind of system that would be extremely lightweight and very strong.
There is a design called a pneumatic air muscle.
Yeah.
Link on the chat.
That's old technology, but nobody's ever been able to control that well.
Yeah, but most.
So Delbert, just one last comment, I guess. Perhaps this might be an interesting challenge for you to pursue. Is to write an article for Servo or even, you know, a book or something about the actual challenges that we've been discussing here in terms of the type of humanoid robot, what it takes, material science-wise, sensor-wise, all of these things in order to build in these safety features to make it viable to be out in public so that it wouldn't injure and so on, and, you know, delineate the various kinds of considerations involved in this. I think this discussion you've had with us about this is really interesting and very challenging to have to think about, really. So perhaps because of your own knowledge, you seem to be rather expert at this. perhaps an article or even a chapter of a book or something might be warranted if you're interested.
Well, I think that's a great idea. And you know, I've been doing this a long time. So to call me an expert just means I'm an expert of 1,000 ways not to do it. I've been trying, and you know, I see what Thomas is doing with Simone, and I totally get how, you know, you start thinking how easy the project's going to be, and then the deeper you get in, the harder it gets, and the more of life's lessons you learn, and you end up needing to become, you know, multidisciplined in physics and machining and metal and material sciences. So you sort of get this education along the way. But I wear a lot of hats, but I'm not an expert pretty much in anything except really the truth is high-speed firmware. That's just what I do for a living. But I like the idea of defining the problem, because if as a club, and I don't mean just your club, but our club as well, if we had enough people interested in defining the problem, then these companies with a lot of money like Tesla might not just go, oh yeah, we're going to build a robot in a year. And, you know, we're going to have a prototype and it's going to, and I'm going, you guys, you've never done it before. You know, until you've done it and you failed 16 times, don't tell me it's just so easy, because everybody says how easy it is.
But Delbert, again, what you just said earlier, that you've tried many things that have not worked, even to document the various things that are not workable as kind of an encyclopedia of things not to do that just are not practical or have problems. I think something along those lines as a guidance to those who are interested in pursuing this, that in itself is worthy of broadcasting, if you will, and delineating, because then people can get at least vicariously a sense of what not to waste their time on and how to be more creative about what might work, really. It would seem to me.
I like that. And, you know, certainly I will use that information that I have in my head of how not to do stuff in the event that a company like Tesla wants to build a robot and wants me to help, you know, on the project. But I want to just say this, just because I haven't figured a way how to do it using the existing technologies and making it, you know, a commercial product, doesn't mean that some brilliant engineer isn't going to come up with something I haven't thought about. And I would love to work with somebody who tells me I'm wrong and doesn't tell me I'm wrong. You know, I'm not interested in anyone telling me anything. It's show me I'm wrong. Build it and show me. I've got, you know, I talk to people and they go, well, why don't you try this? And I go, have you tried that yet? And they go, no, but it seems like a good idea. I go, well, you go waste your time and try it and let me know if it works, because I'm going to build my robot on yours if it works, you know. But I don't, you know, it's hard to build stuff and test it out and to, you know, make it a real product. It's really difficult.
But your experience, again, and I really encourage you to share that in some documented way that could be useful to others. Your definition of the problem and the exploration of all the things that you've done that have not produced what would be a viable, practical kind of thing. I think that kind of, you have some really valuable experience that actually could be a great contribution to those people who are working on these kinds of projects like that.
If you think so, I will take up the challenge and I will write a servo article and try to get it published, you know, on the page before Thomas's of how not to build a bipedal robot.
Hey, my robot's on a platform. My robot's never gonna walk.
I was just teasing you, Thomas.
Well, there's one guy working on it.
So, you
Well,
know,
go ahead.
I think that my next bipedal robot will also only be about 3 feet tall. I'm not interested in building a 5-foot robot because until I can build a 3-foot robot, I don't even want to go with a 4-foot robot. It's just, you know, it's tough.
And the
It gets
cost-
tougher.
What do you think about the Now robot, which is only about 2 feet tall? I mean, that seems like a more viable kind of stature, if you will. That's a little less dangerous.
Yes, and I've seen some of those. People have brought those over to the Robo games in the past. They brought the Now thing, which, if you think about it, is a very expensive $15,000 robot. I don't know the exact price, but I remember it being some, you know, exorbitant amount of money.
It's about
for
half the
everything.
price these days, but still.
Oh, okay,
you know.
yeah, but I saw the same problems I saw with a lot of other people, and I'm going to go on a rant here a little bit. I would not build a robot who runs on Linux. I love Linux. I've been programming in, I mean, Unix was the first real, I worked with PDP-11 stuff, but then CPM and DOS and Unix, you know, and I love the whole idea of what Linux or Unix brought to the table, but it does not have real-time control. It never will, and that's not what its job is. But people seem to think that because it's, you know, they know Linux really well, that, and it's so easy to work under, and so many people know it, that it's the perfect OS. But I think for an object moving through space that has a lot of mass and there's humans involved, Linux is a bad idea. And so my rant on that is that ROS is also, in its current 2 forms, a bad idea. And when I say that, what I'm saying isn't that it doesn't do a great job at what it does. What I'm saying is it's not what it was supposed to be when it was originally conceived. And what originally ROS was, if you go back and look at some of the early documentation, it was supposed to be a communications scheme between sensors, boards, robots, and everything in the world. And it didn't matter what OS you were running, you talked ROS. You talked, you know, it was like a language that you talked, and then they wrote it under Linux, and then everybody just said, well, it's too complicated and everything has to run under Linux. And so initially, Karen has a thing called Spunk, which is a serial protocol, and Spunk is an acronym. It's a serial protocol universal something something, but I like the name. And it basically talked to a ROS node, but shared dynamic information. So without going through DDS and all the ROS2 dynamic stuff, you could configure data on the fly, and you didn't have to recompile the ROS node. It just kind of converted it for you at the ROS level. But at the robot level, the communication scheme was very simple, and it didn't need that Ethernet, you know, 7-layer OSI model to send 3 bytes of information, which is extremely inefficient.
If I could just throw out a thought here, this is where Forth becomes a really important potential language for doing this, to incorporate some of the conceptual aspects of ROS and some of these other robot control type of things, but to implement in Forth, I think, in my opinion, because I happen to be a Forth programmer and have been doing this for years, I think that is one of the languages that really addresses embedded real-time systems, high-level type stuff, low-level type stuff, you name it. And I'm just tossing that out as more of a stimulative kind of thing, because I agree with you. A lot of these kind of stayed in the wool or type of languages that we've been dealing with simply don't deal very well with real-time processes.
Yeah, and I'm going to step down the Forth road with you a little bit. I've written thousands of lines of Forth code back in the late 70s and early 80s when Forth was the big thing, and did it professionally actually myself. And I love Forth for what it does and how small the footprint is. You know, you can do stuff so fast and so easy in Forth once you get used to RPN, and you know and stack oriented languages. So I think Forth is great, but what I wanted to see is sort of 4x4x4, which would basically be TensorForth, where we could sort of do things fast on a GPU. So instead of running 1/4, Forth is so small that theoretically you could do you could process tensor information through it. Whether or not that's going to be better than C++, I don't know the answer to that, or C. I'm a real hardcore C guy, and I'm a real hardcore assembly guy, and obviously, therefore, Forth is sort of like right in the middle, except it's more like Python in that it's an interpreter, but it's way faster than Python.
Well,
You know.
well, there's currently work being done. A fellow named Don Golding is one of the people who happens to be a dear colleague of mine. He is developing an FPGA, which is going to have multiple Forth processors, actually, as a system on a chip, but multiple systems on a chip, which will be an improvement over the Green Array's GA144, for instance. I don't know if you're familiar with that specifically, but anyway, it's the idea that you can design your own systems on chip kind of thing with an FPGA, and that allows a lot of flexibility. So you can incorporate Forth, you could incorporate all kinds of other kinds of goodies to your heart's content, communication interfaces, tensor calculation kind of things, you name it. And it opens up a wide variety of things. So there's work being done on that for robotic projects in particular. And anyway, I thought I would just share that and throw that out too as part of this conversation.
No, I think FPGAs are really, you know, they keep coming in and out of style, but ultimately there's a reason why Xilinx is doing so well. And well, you know, being bought out kind of thing, you know.
How about VxWorks or RT Linux? I mean, RT Linux is a real-time operating system, and it's
how long does it take? How long does it take to boot up?
I haven't used it, but I mean, you know, it's whatever real-time operating systems need, I guess. And VxWorks is quite famous. That's I read here that's used on Mars 2020 rover. VxWorks is usually in the job requirements for NASA or JPL. The requisitions or for positions, but I'd be interested in one. Yeah, I mean, I don't know. Well, RT Linux is closer to what most of us have some experience with. I don't know if anybody is in the former aerospace or current aerospace, maybe they know VxWorks. I don't personally know anybody that knows VxWorks, but it's or if you can even get it for you know, for a home user. But RT Linux maybe.
So what's wrong with something like FreeRTOS? What can't you do in FreeRTOS?
Or
that you do in Linux? That you can do in Linux. What doesn't FreeRTOS have?
Yeah, I don't know FreeRTOS, but that's another one then, right?
Well, I use it and it boots up in, you know, under a second. I mean, it just boots and it's up and running. And I use it in the professional world, and you can squeeze a lot of functionality out of a 200 megahertz processor still. And you know what, a lot of things that people will say to you is, well, we'll just put a bigger processor in there. You know, it's like the processors are so fast today and they're only 5 watts. And I go, yeah, well, you should be running at a 0.5 watt. And they go, well, but you know, Why? We can just run 5 watts. And I go, because you ultimately you have a battery.
Yeah. Well, yeah, that would be interesting. I mean, if you could share anything in the chat about, getting started with the free RTOS, that sounds interesting. I mean, obviously regular ROS does ROS run on it?
The
I mean,
ROS is not, there is a project going on to run ROS under FreeRTOS. And I think they actually have some sort of micro ROS thing.
yeah.
And I would be all for that. I think that that's sort of a good way to go. Again, I try to get my own club, and I go to these Tuesday meetings, these ROS meetings. I don't know if you've been to them, and you probably have. And
I have, yeah.
yeah, so basically what I ask people to do is, can we just define a communications mechanism between every kind of sensor we can think about, or at least leave it open so you could define new ones, and any kind of OS, regardless of whether it's FreeRTOS or QNX or Linux or Windows. Who cares? You want to run it, your job, Windows may be the perfect OS for you. And everyone goes, oh, don't use Windows. I go, hey, it works for a lot of things I do. I don't use it for robots, but I think for desktop stuff or writing a quick program, I can write a quick program in Visual Studio way faster than I can ever write something under Linux using Qt or any of that other crap, because the tool set is just so much easier to work with. It's drag and drop. You click on an event, you put the program in, it's just done for you. So there's a lot of things that Windows is good for, but I don't use Windows for robots, and I don't think you should use Linux for robots. But there should be a communication definition so that no matter what you do, you can talk to the other guy, and you could subscribe and publish dynamically this information. And so that's really what I want to see. But I've talked to people and I go, can't we just define something that isn't been defined already in the industry? Because this idea of DDS is a sort of this paradigm that's used in the networking world and in the big computer world, where you have to share all kinds of big pieces of dynamically changing information, and you need to have this huge complex system with an arbiter in the middle and everything. But that's not what we need in the robot world. We just need to be able to have the Raspberry Pi talk to the NVIDIA board, talk to the at 18 mega board or whatever, or the little microprocessor that is this big with a load cell in it that's self-contained, and all it has is just a little 2-wire interface coming out of it, and it needs to talk to your system, and it should be dynamically be able to talk to it and say, here's the information I have. It's of this type, it's of this size, and here's the speed. Would you like to subscribe to it? Yes. Okay, I know how to subscribe to that. Boom. And the sensor just becomes smart. And I don't want to have to put Linux in a sensor this big because I want it to talk ROS. It's crazy.
Well, maybe the micro ROS sounds like it's on the right track. I mean,
it's in the right track, but ultimately almost this fourth thing is the right track, where we need to go back to being able to take a sensor and running 400 bytes of code and send information out. Because I can do that. I can take a load cell, or I can take an IMU, and I could send the raw information out in under 1K of code and RAM.
What it sounds like you're talking about, though, is like an internet specification for sensors.
Yes, a robot communication system, like an RCS or something we call it.
Well, wouldn't you look to the IoT world for that kind of thing? IoT is already doing stuff like that. I mean,
there's an issue though that crops up when you start talking about communication stuff. If you're communicating with a single-threaded processor as your master control, it can only respond to one request at a time. So in order to make that work, you need a queuing and buffing process. And that means you need a hardware specification to go along with the messaging specification. Now, one of the places that's been dealt with in some depth is in the test industry. They have something called the STDF specification, which is a standard test data format. And so you can write the code to do that. It's actually a record-based format for sending data, and it's all kinds of data. But you end up having to have buffering and all the rest of that stuff with it. And you don't get that with small sensors and processors yet. The closest processor that kind of did that on really low power was way back in the 1960s. RCA built this little bitty processor that ran on 5 microwatts of power. I think it was an 8-bit processor. They sent some of them up in satellites and stuff. They were even
Was that the 1802?
May have been. I don't remember what.
Yeah, I've used that.
Yeah.
So
And
I,
it was used on some of the early warning satellites.
Yeah. So that
It's
was
very low power CMOS processor, and one of the reasons it was used on the satellites is because it was radiation hardened.
Yep. That's probably it then, because that was the conditions I was thinking of, was really low power and rad hard. So something like that would work for sensors and stuff, but the technology that it would be required to embed that is more expensive than the processing technology they use to build sensors these days, which are typically the 10 or 15 nanometer standard silicon processes. So I don't know how you would get there. The idea is very appealing, but when you start thinking about what's required to make that work, it becomes more complex than you would expect. Just kind of like building a walking robot.
Yeah.
What about the IoT world and the like Zigbee and you know, those?
Yeah, so I'd like to address that a little bit, because I've done a lot of that IoT stuff, and basically you're running a protocol stack, you know, like the Wi-Fi protocol stack thing. So you're back to this 7-layer OSI model. You're back to huge amounts of RAM in order to maintain that stack, and ultimately you don't really get any benefit out of it when only certain information is going back and forth across, you know, a line. A simple differential receive transmit line, 3 wires can do that. And there's no reason why we don't, you know, why we're not building little processors with I2C. People love it. I like SPI better, but you know, ultimately something to take these little micro sensors and just make them this, you know, the size of a quarter, and with a wire coming out that plugs into a distribution board that can sit there and grab all that stuff up with a big processor that has, you know, megabytes of RAM, you know, but I want to build a little microprocessor with 1K of RAM and attach it to the sensor, and I want to be able to dynamically change how the data is presented over this little line. And we're not talking about a lot of bytes here, or even the frequency. It doesn't have to be, you know, it could be something as a packet every half a second or something.
The technology that's evolving is going to require more bytes than we're using now. If you think about a touch sensitive skin, for example, or like in a hand where you would want a sensor that could measure pressure and temperature and roughness, you end up with a lot of data being transmitted in order to convey the information that you need to convey. And I don't know how you're going to do that with a really simple interface, because you still need the data space and buffering. The individual sensors may not need that, but the communications protocol and the way to receive that data becomes much more complex.
I agree with that, and this is why I think this is why a definition is in order, because to answer that question, if you said, well, how would we solve the skin sensor issue where you might have 1,000 sensors in an area that's, you know, that big, you need to have some sort of defined mesh protocol, and basically, you know, how does the data pass through the mesh, and ultimately, I don't think that's it's not undefinable. We just have to start asking the right questions.
What about back to just you know, what I started with is an Arduino and you know, a few sensors like a ultrasonic or a color light sensor, and running it. It's all on I2C or many other sensors, temperature, whatever. There's hundreds of sensors for Arduinos, and those are real time. It's a really small amount of code, and they run over a couple of wires. I mean, we've been there before. That's called microcontroller work, but it's not sophisticated enough to handle a lot of messages and all that, right?
Well, so Dan, what if I were to make the argument that I believe the answer to that question is sitting on your desk right now with that brushless controller? Um, uh, CAN bus can seems to tick all the boxes. It can be distributed. You can string a whole bunch of them together. There's a lot of bandwidth that seems to be pretty resistant to spikes and other stuff. Would that more or less fit for the type of IoT sensor communication that you're looking for?
You know, I think it's dependent on the user's application. If I want to send a lot, so you're right. So this works on FD-CAN, which FD is, you know, a little bit, it's got like 5 megahertz or something. It's a lot faster than the old 250 kilohertz CAN stuff. But CAN isn't for everybody. I mean, you know, if you have a mesh network, CAN is gonna, I mean, CAN, you could use the 29-bit encoding CAN, and you could theoretically, you know, run a whole mesh network based on CAN, but CAN has a huge overhead. I think it's you know, the data packets, you know, like, you know, the ratio between data and the rest of the stuff is like 50% waste. So, you know, when you're doing a mesh network and you need to pass all stuff through little processors and have it filter all the way through, I'm not sure that CAN is the solution, that there's no one solution. All I wanted to find, that's why I sort of wanted to create a list of not how we would solve the problem at first, but can we ask all the right questions as to what everybody really wants first, rather than building something that we think everybody wants and then shoving it down their throat and saying, well, here's how you do this. You know, here's how you run your turtle bot and everything. And that's great. But then all you ever get, you lose creativity that way. You just end up with everybody following the other guy, you know?
Yeah, it depends on how much time you have. You know, most of us have jobs and, you know, have a few hours in a day, maybe, or 1 hour and a few hours in the weekend. You want to stand on giants of shoulders.
On the back shoulders of giants. That's great, except I've been working with Ross. I've worked with Ross a number of times and always had a huge learning curve and never got things working right. I work with NVIDIA, with Linux and their Jetpack. And like I said, I go on what's supposed to be Linux. You know, it's like, okay, just download these containers. Well, guess what? You need a whole education in containers now, so that you can run containers. And you know, and it's not cut and dry, and documentation's kind of sucky. This idea that we're going to create this, what we call Doxygen style documentation, which is we take the header files, we put some funny little characters in it, and we automatically create documentation from the header files. Well, that's sucky because I've already read through all the header files. Now I need additional information. So they go, well, look at the document. I go, but the document is based on the header files. Don't be lazy. Don't be lazy.
You need more than that.
Code is an oxymoron.
You need, yeah. Well, you can do it better and you can do it worse. I mean, you know, but you need more than the Doxygen. I agree. But you know, that's what tech support is for. If you buy something from a company.
No, tech support doesn't do that job.
Well, okay, not tech support, but maybe
designs the software, and the guy who designs the hardware has an obligation to provide information to the people who are going to use it. And nobody teaches that in the colleges these days. I talked to engineers back when I was working in the companies, and the engineers were basically incoherent. I mean, I'm sorry, but you can be very, very smart in intellectual capability, but if you can't express that to other people so they can understand it and utilize it, you're essentially stupid for the practical purposes of society.
Oh yeah, yeah. I mean, I think that it's the laziness factor of, documenting your code and then writing nice, but what I meant was, I mean, I've had personally good experience buying a product that was a programmer level product, like the SlamText Slamware API, and getting decent support from a level, a high tier level support person, not like regular, Samsung tech support. We're talking
That's
professional support.
the worst thing that happened to the tech industry is a company that built a product called Citrix. Have you ever heard of it?
Yeah.
Yeah, what is that?
Every time you call a customer support line, you're getting a person who knows absolutely nothing. They're looking at a screen that
Yeah.
comes up with the common responses, and it is useless.
Yeah, it's like a chat bot now. The intelligent chat bots, that's their solution for it. And just to give you a quick example, in real time now, today, or 3 weeks ago, I have a client of mine that was using a Wi-Fi module in their medical device. And the company that made the Wi-Fi module stopped making that module, and it wasn't 5G. So we went out to get the only 5G module that, worked on SPI and Serial, and it was TI. TI had this thing called Simple Link, and they still have it. I mean, they use it. And so it's a huge learning curve, and they do everything in their own little libraries, and they want you to sort of just follow their paradigm. But if you want to move data fast, you can't do it with their product. And so you go and you say, well, how do I want to DMA this into a ring buffer and blah, 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 blah. And they basically have no clue what you're talking about. And they say, well, I said, can I talk to someone in tech support? They go, we only handle tech support through the web, through our, you go online to the forum and you pose a question. And there's one person on that forum who's brain dead. And the reason they're on that forum is they've been working with the product for 10 years, but they're not really programmers. They don't know how to get outside their own little box, and they can't do anything that isn't down and that's the ordinary. So, now I'm stuck with the only product in a medical device that has to push information up to the hospital fast, and these guys don't know how to do it. And you can't talk to any of the engineers. You can only pose the question in their forum.
You used to be able to talk to the engineers.
Yeah, you used to be.
This is a mic check, by the way. But yes, I used to call up Texas Instruments, and quite literally, I would get to an engineer. This is back years and years ago, and the engineer would do all the work for me and then email it to me, and it was just a pleasure.
Yeah, where is that today? And
That's gone.
Yeah,
all gone.
So all I said is, okay, can you just show me an example program that uses your DMA in a ring buffer so that the information coming over the web isn't lost, because it's coming faster than it seems you guys can handle. And they go, well, we don't write code for you. That was their response. I go, I'm not asking you to write code. Just show me an example where you can prove that it can push data at the speed that you say.
Like a white paper.
Yeah, well, their white paper says that their serial port runs up to 2 megabits, but ultimately they can't really run faster than 115K. Because their program has got so many levels and layers of indirection to it. These guys they're writing one piece of code to handle multiple pieces of hardware. And so their code is extremely inefficient. It doesn't really leverage their hardware. It's sort of just, well, we have hardware layer 1, hardware layer 2, then this layer and that layer and this layer, and it passes all this stuff. But look at the beauty of this thing. When we redesign the processor, all we need to do is to change this one little layer and everything works. I mean, this is this goofy idea that's how you write systems. That's not how you write systems. It's bullcrap.
Well, the thing you see is the companies want to be able to hire people who aren't engineers to write code.
Yeah.
That's this huge push on the internet right now for low code, no code.
Right.
And you see professors pushing that idea. Well, who the hell's going to write the basis that runs under that low code, no code interface?
Yeah.
Well,
we need a new name for them. We can't call them programmers. We have to call them something else. That's the
well, now I think
high school students.
Yeah.
Oh, that's cool.
Kids
That's
in Nigeria
cruel.
got the OLPCs.
Yeah, so it's like, so we went to this ST Micro thing. It was an embedded thing, embedded world. Go up to the ST Micro guy and going, hey, we're using their the F7 something processor. It's 200 megahertz and everything. And we're running like these 16 pieces of hardware in there, which included all DMA stuff, all 1,000 times a second, reading 8 channels of data on this EEG machine. And we're streaming to the cloud, and we're writing to the SD card in a fat file system, and we're doing all this stuff. And they go, well, you can't do all that with this little processor. And I go, no, not using your driver routines, we couldn't. Not using your HAL, because it's too slow. It's like we got 3-to-1 performance improvements over their HAL.
Right. You can improve an Arduino just by running with a system that uses interrupts to process data.
Yeah.
Yeah, I mean, did you, I don't know, Alan talked right after I did, but did you hear my comment about Arduino? Like, and I mean, it seems like you're pointing back to basics. Go back to your microcontroller, go back to your I2C, and what's the other one? Those low-level interfaces. But programming that I could do some stuff, but it's very limited. I mean, I had
You have to do the advanced stuff. That's the problem.
What's that?
When you try to do the advanced stuff, that's when you run into the problems.
Yeah, but I mean,
As soon as your process gets complex enough, it quits working entirely. It just fails to process data, to handle the information, or whatever it does, and lots of problems.
Hey guys, we get about a half hour left.
Okay.
So
Why do we have a half hour left?
we have about a half hour left.
12 is the normal end.
We can come back to this
Thomas.
subject later. Hello.
One thing I wanted
Thomas,
to say. Go ahead.
I'm trying to interrupt everyone to move us on. We wanted to do a couple of show and tells. Again, I want to thank Dan Albert. Thank you again, Dan.
Thank you, guys. Sorry, I wasn't
Appreciate
better
it.
prepared.
Thank you.
Everybody's welcome to stay on. We're going to do a couple show and tells, and if you want to revisit this after the show and tells, that'd be wonderful. Buzz, did you have a question? Buzz?
Yes, I wanted to know if Dan would be amenable to having a private conversation with me at some time.
I'd be happy to. Let me just.
Is there a way?
I'm going to just put my email address in the link here to anyone that wants to contact me, and then you can contact me at my company, which is it's Daniel at 0.1 seconds. I could spell.
Thank you. I appreciate that, because
Yeah,
I'd like to just have a chat with you.
Yeah, and obviously you can tell from my domain name that everything I do happens in 100 milliseconds or less.
Understood. My kind of guy.
It's
Thanks,
a law,
Thomas.
it's a lost art. I mean, people don't know how to do it anymore. Only the real hardware engineers know how to do that. And the thing is, if you're going to work with sensors and stuff like that, and you need to push your data through, you better be reading the data sheet of the sensor. You better be able to read it and understand everything about it before you start writing a driver and working with it.
Yeah.
Oh, I agree. I mean, and I'm a software guy.
Like I say, the people that are doing this sort of engineering work now really don't know what they're doing half the time.
All right.
All right, guys, moving right along. Oh, I want to show that video that Tim posted. That looks really interesting. It's from Disney Imagineering. And we're just going to run through that for 30 seconds. It's about a 1-minute video, and then we'll move on. I believe, Jim, are you the first one up for a show and tell? Jim,
Dan will like this video.
Yeah,
I am.
Go for it, Jim.
Which Jim? We got 2 Jims up there.
No, Jim U. Jim U.
Uber Setsik.
You were sexy. Okay, I'm going to run the video first, and then you're up after that. All right, Jim?
Okay.
All right, let's run the video. Gonna move my screens around, share my screen. I've got it all queued up, so. And. Okay, let's share screen. And optimize for video. Screen, there we go. YouTube share. You guys see that?
Yep.
I could bring it back.
Hey, can you see the video?
Yep.
Let's see him jump.
Yeah, that's impressive.
That's very nice.
That's
Yeah, what Disney did is hired away one of the programmers from Boston Dynamics.
It's better than the Honda Bot.
It's smaller than the Honda Bar.
You mean Ozzy?
Yeah. Yeah, it's the height that means everything, right, Dan?
It's the height and mass.
Okay, who's got the second microphone on? Will somebody kill that second microphone?
Yeah, sorry, Jim Ubersetic. I went ahead and muted you. We're getting a lot of feedback from your mic.
Okay, let's see. How do I unshare? Oh, stop sharing. Got it. All right, Jim, you're up.
We're still hearing that though.
Yeah, somebody needs to get a set of headphones, I think, because they're listening through their speakers.
Well, we could all press mute.
Test 1, 2, test 1, 2. That sounds good now, guys. All right, Jim.
Okay, this is a voice check. Do people hear me?
Yep.
We do.
Okay. All right. I have an application for a physically small LiDAR sensor, and Jim D'Annunzio told me recently about this one. How about this one? Can people see that?
Yep.
This is a small LiDAR. It's a two-dimensional scan LiDAR that Jim D'Annunzio told me about recently. It's very promising, but I would like to know, does anyone in our group have experience using this small LiDAR sensor? It's a two-dimensional LiDAR sensor with 180-degree scan, 100 hertz scan rate. One scan is about 200 distance samples. And it has a number of interesting interfaces, including SPI, I2C, and UART, which means I'm not stuck with something like USB. And I like that idea. Question is, does anyone in our group have experience using this very small LiDAR sensor?
I think you mentioned this last time.
I did, but it was past the end where there was no more recording and a lot of people had already left the meeting.
Oh,
which is why that's why I'm asking again when everybody's still here.
Yeah, this is pretty new, right?
Apparently it's a little new. I found out about it last year in issue of Servo magazine, the article was written by John Blankenship, and in the article he claims he was a beta tester for this sensor and apparently had fairly good luck with it. However, before I spend the money to buy one and also put in a lot of my time to learn how to use it, I thought I'd just ask if anybody else in our organization has already used it and might be able to tell me something from their experience.
Well, if not here, I would post to the homebrew robotics list in Silicon Valley.
Okay. All right, I'll try them.
Yeah.
Thank you. I guess that's all I have then.
All right, thanks, Jim. Moving right along, we have.
Now, how do I cancel this?
Oh, it's at the top. There should be a. You have to
Stop share? Okay.
Yeah.
Stop share.
All right.
All right, thanks, Jim. Moving right along, I want to give some time to, who was it here? Jason? Jason, are you here? Jim, can you mute yourself? Jim, you oversets it. Can you, thank you, Jim. Jason, are you here? No Jason today? Has he left? Jason or Chandini? No?
I see he's still on. Maybe he stepped away for a minute.
Yeah, Jason's still on.
Jason,
Oh, we can come back to him.
I guess we'll have to.
Yeah.
Oh, he's there.
Oh, you're back. Okay, you got something to share with us today?
Oh, yeah. So I was just going to talk about this robot that I've been working on.
Just a second. Are you Jason? Are you Chandini?
That's my mom.
That's your mom. Okay. Sorry. Go ahead. You got the floor.
Okay, yeah. So I was just going to show you guys quickly this quadrupedal robot I've been working on. It has like 12 small servos. So each leg can move like that. Then I wrote a program for like a simple walking gait. So I could show that to you guys now. So it has this walking gait. It works all right. The robot does tend to fall over sometimes. I did add a IMU sensor so it can detect how much it tilts. That worked. It worked well enough for it to be able to walk on carpet. But when there were like obstacles or uneven terrain, it would usually fall over. And I also did use these low torque servo motors. So instead of trying to improve on this design, I think it would be better to do like a redesign and use these larger RC servo motors to create a robot that's about the same size, but the motors have higher torque. Like this leg. This is the one that I've been working on recently, but this is one that I worked on a couple of months ago. And the main problem I had was that these servos didn't have enough torque to actually move the robot in some instances where the robot's leg would get stuck on the carpet, or if it all the weight was supported by only two legs of the robot would kind of fall down and sink into the ground sort of, because the motors weren't able to actually hold it up. So that's what I worked on, and now with like the knowledge I gained from this, I'm going to work on another version, so it'll be stronger and a bit smaller actually, so I'm not stuck with the same problems with torque and stuff like that.
That sounds good.
Yeah.
How long have you been working on this project?
This one actually took me about 8 months. 8 months. Yeah, just understanding how to work the inverse kinematics model and moving the legs around.
But what does that run on?
Just an Arduino Uno. Then I also have this motor controller. I use the Adafruit PCA 9685 library to run the motors. Yeah, so it has 12 motors. Each drive, servo driver can hold up to 16. I didn't need to use all the servo slots for that. Then it just runs on this RC car battery. It's rechargeable, so the motors are powered with one power supply and the Arduino is powered with another.
How much code did it take? I mean, to do the inverse kinematics on the Arduino, like,
The model wasn't too complicated, really. It was usually just using basic geometry to work back and understand the angles. For the whole entire robot, I'd say it took about 500 lines, but it could be improved, shortened. Definitely, it's kind of sloppy. So if I were to go back and do it again, I could probably reduce it to like 200 to 300 lines of code, make it more concise and work better, probably.
pretty good.
Mhm.
That's. And what libraries did you use? Any other other libraries besides the motor? You said, I think you said the servo control library.
Yeah, I actually used a library for the inertial measurement unit, the IMU, that so it can tell how much it tilts. I used another library for that. I forgot which one that was called, but yeah, I used that library. That worked all right. There was some noise with the actual readings, so I did write a piece of code that would adjust the robot's legs length depending on how much it tilted. But adding that to the walking gait didn't really work out because I couldn't really read the inertial measurement unit at the same time as I was running the motors because of power problems. So I'll probably be using like multiple microcontrollers to control the different sensors, so there's less noise and stuff. So
Do you know which IMU do you use?
I believe it's the MPU 6050.
6050.
Yeah, it's one of those.
Cool.
Yeah, so that's what I've been working on now. So I'm starting to work on like a new model with different servos. So then I'll see how that works out.
Wonderful, very good. So you'll be working on this the next few months. We are going to expect to see updates. All right.
Yeah.
All right. We're here for you. We want to see what you can do. It looks wonderful, Jason. Thanks for presenting that.
Thank you.
We got about 15 minutes left. We have Jim D that wants to show something, a brief demo on the Oak D and human recognition. Jim, is that how long would that go?
It just takes a few minutes because I've got it trained. I just want to show you. I just want to show the beginning of how it's going to work in my robot. But
okay, and then after that, we got Alan that's going to talk about his new voice. Just before we go any further, I do want to make an announcement before I forget. The Aquarium of the Pacific, you guys know where that is. Most people do. They have their Robot NC exhibit that will be first Wednesdays and starting October 6th. If anybody has any other information, who from the club is presenting something over there? I know a few of us are, aren't we?
yeah, I am.
Anybody else?
Yeah, it looks like Carl has his hand raised.
Yeah, Carl.
Yep.
Yeah, I'm going to share my screen on that. So you guys could, the link's in the chat, but I'll just share my screen. There's their web page. Whoops, I just closed it. Okay, try that again. Didn't mean to do that.
Yeah, that should be a great event. It's open to the public. It's free, except for parking. It's like $7. And there's going to be a talk by a USC robotics professor and head of that department on underwater robotics, naturally, because it's an aquarium.
Will this be
An
online?
RSVP is required, yeah,
An RSVP, yeah, okay.
for
That's
the
important.
lecture mostly. Yeah.
So
Yeah,
this
that's
is strictly a live event?
This is an in-person event. Yes, I don't know if we have no idea if it's being recorded or anything.
I will call and see if they're going to stream it.
Yeah,
I
you,
would-
if it does, I didn't see anything about that in this document, but give them a call.
Yeah, I want to see if they wanted to get a mermaid, and I don't know if anybody wants to help me on a mermaid project.
Oh,
You
really?
know, yeah, I build these life-size robots. Might as well build a mermaid. So
Might as well.
I think a mermaid tail would be much easier to apply motion to than
yeah, at
feet.
least it doesn't have to walk. I don't know if we can get it swimming, but if it could just sit on a rock and just wave to people, I think we've got most of it.
I
Well, then-
don't think we want to get it wet.
No.
Hey, then Disney can bring back mermaids to the 20,000 Leagues submarine ride like they had in the 60s.
That would be fun, wouldn't it? All right, I just wanted to get that in. So next up, is there anybody else? I mean, Jim and I and Alan, we always talk. So anybody else want to get theirs in before we end off here?
Can you post that link that you just had in the chat?
It's in the chat. I'll repost it if I
It's
can.
it's up higher, but yeah, you can repost it.
I'll repost it. Carl
It's at
put
the
it in.
No, don't make me scroll. I'm just kidding.
It's near the top. You could just go to.
There, I reposted it.
Thank you.
Stop being.
One of these problems with the chat window.
Yeah, it doesn't retain it. That's the problem. So since we have no other show and tells, I'm going to turn it over to Jim. Jim, what you got? And save a little time for Alan.
Yeah, no problem. So I'm been working, I'm continuing to work or starting up again to work with the Luxonis OAK-D stereo camera. And this is it here. Oh, let me
Background's fading it out.
let me get rid of the virtual background here. So a lot of people have been asking, can it identify or recognize a person by name? Here's the camera. And so I finally getting around to doing that. And yes, it can. And it's one of the it's one of the supported combinations of modeling of a machine learning model that's available for the camera, done by a third party. But so for let me you should be able to see my screen now. I won't go into too much detail, but it uses 3 different models. It does a facial recognition, then it pipes the results of that into a facial landmarks model. These are all machine learning models. And then landmarks sort of determines, where the nose and mouth and eyes and stuff. And then it feeds that information into a facial recognition algorithm, or not algorithm, but machine model. And then it matches that with a database of previously recorded information from a gallery of people. So you essentially take the camera, run this program in this kind of recording mode. It then runs that sequence and gets data on you, and you tell it your name, and then it stores that in a database, and you do that for several people. And then when you run it, in non-recording mode, regular mode, and it will do the same inferencing on what it's seen, or through a video. You don't have to you can pipe a video directly, or you can pipe from the camera. And then it does this thing called the cosine difference between what's in the database and what it's processing right at the moment. And then it is able to give you a percentage probability that this is person A, B, or C. So that's just a quick rundown. So I'll show you here. While people were talking, I ran it on Jim Uberzetze, Les, and Dalbert, and of course I've already done myself. So I'll show you, and hopefully I'll show you on me first, and then and then hopefully I can bring up the gallery. So can you see that where it says Jim? Can you see a video of me on that screen there?
Yeah.
And so it's a confidence is, it's above 50, 60, 70. And I'm sure the amount of recording that you do can change, the number of angles you when you're in recording mode will affect how good the data that's captured. And so now let me, I wonder if is there a way to bring up the gallery. Oh, I guess I do this. So now I'm going to look at the screen here. And I can't cover that though. See if this will work. So hopefully you can see in the left there.
A black. Are you showing anything?
Yeah, I'm showing. You should still be able to see my screen.
It's a small part of the screen. Oh, you identified Jim. Look at that.
Can you see where it says now?
Yep.
Jim U. And then let's go down. Can I pin? This is hard to. You can see it now? Then here I'm gonna.
It's real tiny, Jim.
Or okay, let me. How do I? Let me stop share and then. Well, the
Yeah, you may
problem
just
is I
want to
have
share a window or a portion of the screen. That might make it easier to see.
Yeah, how about I share? Yeah, just this. I mean, this is going to be kind of small, but might be the best I can do. Okay, so now you should be able to see. Right, okay, so I see the green boxes. You should be able to see just that one view with the camera view now.
Yeah.
Now, I can't make that camera view. Well, I could make it bigger, but it might take too long. So here, can you see that where it says, it's saying, sorry, it's not very stable there. See, it says less.
Yeah.
Yes, we see less.
And now,
Click your maximize box on the window.
oh, this, you mean, okay. Is that any better?
No, the other one.
Yeah, but this doesn't, that's a set size. I have
Oh.
to change. That's a set size because of the model.
You'd have to change the resolution of the monitor.
Yeah, I can change the, I could probably change the resolution of the PC here by, I don't want to waste the time, but
Yeah, that's
can
fine.
you can see it says
So-
less, and you can see it says Jim U should, oh wait, is Dalbert still here?
His
That will-
name's Dan.
What's that?
His name's Dan.
Dan?
There you go, Dan.
Yeah. See, well, depending on how good the quality is, it might get confused, but it's doing pretty well for this like crude demo. And I only recorded just off of the screen.
So this is all done in real time?
That's real time, yeah.
Nice, very nice, Jim. And
So
you're
anyway,
not
I'm gonna incorporate that into the orange, and so it'll have the full ability to say, introduce yourself. I am so-and-so, can you please remember me? And then from that point on, you can, it commands to the robot to go to a person will be able to identify that person to some degree. So that's like, can you take this drink to Joe at table 2, which is what I'm going to have to do at the aquarium. And or I'm going to try anyway. And then it will go to the table 2 and look for Joe that it's previously met.
What
Anyways.
kind of What kind of processor does the image processing for you there?
This is the Oak D camera, which uses Luxonis. It's the Luxonis company, and they use the Myriad Intel Myriad processor that does inferencing and can handle the whole suite of OpenVINO models. It runs these models on board the camera, but it doesn't do OpenCV. OpenCV is just on the PC, but it does all the inferencing for the neural and stereo disparity and all that. We posted the Luxonis link earlier, I believe. It's a great camera, and there's several different products that they have, non-stereo as well as stereo, and there's a new one coming out. But the power of all the AI models is unbelievable. I mean, there's a lot available already. Does that answer your question?
Yeah, above and beyond.
Okay.
And what's it running for these days, Jim? How much is it?
For this one, this is $200. It's really, and then they're coming out with a small one that will fit on smaller robots, and it's only going to be 150. And right now it's you can get it cheaper than that because it's still in a it's still in a like Kickstarter type. I think it's still in Kickstarter, and so the price is still lower than the retail for the other one. That's a small one. That one's not out yet, but this one is. But they might, yeah, I'll give a presentation on this in the future, maybe in the next month or two, and to give you like a rundown of all the things it can do. Although you can go to the web right now and to the documentation for Oak D, and you can see, if you're interested before then, and you can see all the different models that that are out there that are available for it, machine learning models. So it's quite powerful and quite, it's real time, and it could be extremely useful for your robot application.
Jim, a quick question. What is this cosine difference? Is that a well-defined algorithm?
Yeah, well, I'll get back to you on that because I'm not really prepared to, give you the rundown on it, but
well, actually, what caught in my mind is a memory of something called a discrete cosine transform, which was used with some types of video processing. I don't know if they're related or not.
Yeah, I'm not sure of that because this one it's more of like a distance calculation of some sort, except it's maybe it's a phase difference. I'm not quite sure why it's a cosine difference, but let me get back to you on that. I'm really not prepared.
That's fine. One other quick question. Now that I have unmuted my microphone, are you still getting feedback from me?
I'm not hearing much. Anybody?
Okay. I had the volume turned up loud here earlier, so maybe that was why. I turned the volume down since then.
That might have been it. All right, well, thank you. We'll move on to the rest, to Alan. We're back.
Yeah, and we're actually at noon right now, and I'm a strong believer of wrapping up the main meeting on time. Yeah, let's what's going to happen now is I'll turn off the recording. I'll leave the Zoom open for open session, as Kemp calls it, random access, and feel free to chat about whatever you'd like.
Well,